So now in this video, we want to specifically focus in on quadratics and a specific type of quadratic, a trinomial quadratic where a is equal to 1. So first, what do we mean by that? Well, in general, we say that quadratics have the form ax squared plus bx plus c. So quadratics are degree 2 polynomials, and that means that you can have at most 3 terms, right? Which would mean that they're trinomials. And when we say a is equal to 1, we're saying that the leading coefficient here is 1. So for example, maybe this would be something like x squared plus 5x plus 4. Okay, and we want to learn how do we factor these, because these are very common. These very commonly come up. So in general, we kind of want to think about foiling in reverse. Okay. So we want to think, okay, if we had 2 binomials, we saw that when we multiplied 2 binomials, we would often get a trinomial, especially if we had 2 linear binomials like x plus 3 and x plus 5. We multiply them together and we get a trinomial quadratic like this. So we know that we'll probably end up with 2 binomials. Okay, we can kind of reverse engineer it. What do we know about the terms inside these binomials? Well, we know the first term must be x. And that's because we know when we do the foiling, when we do the first, outer, inner, last, when we do that first part, we're going to do x times x and we're going to get x squared. Right? That's pretty much all we can do to get x squared, because that's what x squared is. It's x times x. Now the rest of the terms are a little more open-ended. We know that when we do the last part, when we do this, whatever this number is in this one, plus whatever this number is, we're going to get 4. Let's call them a and b right now, just to give them names. So we know that a times b must be equal to 4. So what do we know about the 5? We know that when we do the outer and the inner, we're going to get ax plus bx, right? And we're going to combine these because they're both x terms. So we're going to get a plus b x. Well, we have 5x. So we know now, this means that we know that a plus b is equal to 5. Okay. So this is the general strategy. We're looking for 2 numbers where multiplied together give us 4 and added together give us 5. And I'm realizing now maybe it's confusing that I'm using a and b over here when I already used a and b over here. No relation down here. These are completely separate. They don't have anything to do with the a and b I wrote up here. So let me just erase that so that we don't have that confusion. So anyway, so now it gets kind of into guessing and checking what numbers will work. So there's an infinite amount of combinations of numbers that would add together to give us 5. So let's focus on the ones that multiply to give us 4. Okay. So if we think of every combination of numbers that would multiply to give us 4, and we're just thinking about integers here, we're not thinking about like fractions or anything like that. Then we have 4 times 1, 2 times 2. We also have negative 4 times negative 1, and negative 2 times negative 2. So we look at these are all the combinations, and we look at, okay, which one of these sum to 5? Positive 5. And we get 4 times 1, right? So our answer here must then be x plus 4 times x plus 1. Sure enough, we can go ahead and check to make sure that it works. X plus 4 times x plus 1 is x squared plus 4x plus x plus 4 equals x squared plus 5x plus 4. Okay. So this is the general strategy with this specific case. We want to look for 2 numbers that multiply to give us the last term and add to give us the middle term. And we're only considering cases where this the leading coefficient is 1. So we're always going to have x and x on these cases. Okay. So if we have maybe x squared minus x minus 6, okay. So this one's a little bit trickier because we got to consider the negatives now. So we have x and x. And now we have to think, okay, what two numbers multiply to give us negative 6 and add to give us negative 1? So again, we'll just think about the ones that multiply to give us negative 6 first. So we'll have 2 times negative 3, negative 2 times 3, 6 times negative 1, negative 6 times 1, and I think that should be it. So now we want to look at these combinations here and see, okay, which one of these add to negative 1, and maybe you want to add all of them, however you want to do it. Okay, so the first one's going to give us our answer, but if we just went ahead and do all of them, just see what they are. So the first one is the correct answer, right? So this is going to be x plus 2, x minus 3. Okay. Let's look at x squared minus 13x plus 30. Okay. So again, we'll have x and x. And now we're thinking of two numbers that multiply to give us 30 and add to give us negative 13. So if we just think about what this means, we know that if we take two positive numbers, which would multiply to positive 30, there's no way we can add them to get negative 13. So we can see right off the bat that we're going to have two negative numbers, because two negative numbers will multiply to positive 30 and can still add to a negative number. So that kind of limits our options right away. So namely, we have 30 times 1, 15 times 2, 10 times 3, 6 times 5. Okay, I might have missed some, but we can see the 10 and the 3 are the ones that are going to work here. Namely, we're considering the negative versions of all of these. So maybe I should write the negatives out. But negative 10 plus negative 3 is the one that's going to give us negative 13. So it's going to be x minus 10, x minus 3. Okay. So now some special forms. What if we have x squared minus 16? Now we don't have a middle term. So we say b is 0. The middle term is 0. Well, two ways we could think about this. One, we could think, okay, well, this is just x squared plus 0x minus 16. So let's just go ahead and do it like we normally would. Let's find two numbers that multiply to give us negative 16 and add to 0. If they're going to add to 0, one of them has to be positive, the other one has to be negative, and they have to be the same absolute value, right? So like 2 and negative 2, 3 and negative 3, something like that. So here we're looking at 4 and negative 4, because those are the numbers. That's the only thing that when you multiply by itself, you get 16 is 4, right? So this is going to be plus 4 and minus 4. So when you add these, you get 0. When you multiply them, you get negative 16. Alternatively, you recognize this as the difference of squares formula, which tells you that when you have two perfect squares being subtracted, this is how you would factor it out. So we did it for the multiplication side, but now we're doing it for the factor side. So if we have y squared minus 121, we know that this is y plus 11 times y minus 11. Okay. And on these ones, we don't even really need the leading coefficient to be 1. We can do it just as well if it's like 4x squared minus 25 or something like that. Okay, then we have 2x plus 5 times 2x minus 5, right? Because 2x times 2x is 4x squared. So we want to get used to recognizing these forms because they kind of can come up a lot So if we don't have that middle term, this is something we should be looking at. Like, is it a difference of squares?